Today, we're starting a brand new series of tutorial videos on generating procedural patterns and shapes with shaders. Let's go! I hope you're excited for this new series because I am. Let's take a minute to talk about what we'll be doing in the videos in the next few months. We'll be creating signed distance fields, tiling patterns, compound shapes and user interface elements, and more, all using shader math. There's a lot to cover in this area, but first, let's step back and talk about why. Why do we need to learn to create shapes and patterns with math in the shader? Here are a couple of reasons. First, for performance efficiency. Most of the shapes and patterns we're going to create could very easily be created using a texture map instead, but sampling a texture is one of the most expensive things you can do in a shader. So if you're able to generate a pattern using math instead, it's often more efficient to use that method than to use a texture sample. Next, resolution independence. Using shader math, it's possible to create shapes that are resolution independent. If you need to be able to scale your shape up really large on a high resolution display, or allow the player to zoom in really close, procedural shapes generated with math are a great choice. Doing the same thing with a texture would require a very large texture map that would use a lot of memory. Which brings us to our next reason. No texture memory. Procedurally generated shapes and patterns don't use any texture memory at all, which means that using them leaves you more memory for other things. Next, dynamic editing and adjusting. Finally, because procedural shapes and patterns are generated on the fly, it's very quick and easy to adjust them using material settings or small shader adjustments in the game engine. You don't need to leave your game engine to edit your textures in an image editing software and then re-export them. So there's not this back and forth round trip import-export process. So making changes is fast and easy, and your iteration workflow is smoother. Not only that, but dynamic adjustments can also be exposed to the game, so the game or the player can also adjust your patterns. This opens up all sorts of interesting opportunities that aren't available to create with static texture maps. So one of my main goals in this series is going to be to help you to build up a library of shader nodes, subgraphs in Unity, and material functions in Unreal. Once you have this set of nodes, it will be easy to combine them together to create new shapes and patterns quickly. It will be a powerful tool for you, so we're going to put a lot of focus on building up this library of nodes together. Today, we're going to create our first two nodes in the library. So we'll start out in Unity, and then in just a minute, we'll switch over to Unreal, and I'll show you how to do the same thing there. All right, so here we are in Unity, and you can see that I've set up a new project, and I have this folder called Shaders, and another folder called Procedural Library. That's where our subgraph nodes are going to live. And then inside our procedural library, I've created two folders here. One's called Gradients, and one's called Helpers. The first node for our library that we're going to create is a linear gradient. So I'm going to pick my Gradients folder and right-click in here and pick Create Shader Graph Subgraph. And I'm going to name my linear gradient, well, linear gradient. So let's open up our subgraph, and we'll get right to work. The first thing that I need to do is create a couple of inputs for myself. The first one is going to be a vector2, and I'm going to call it UV, and I'm going to drag that in. And then the second one that I'm going to create is going to be a Boolean, and I'm going to call this one invert. Now the goal of this subgraph is to give us a linear gradient that we can use in all sorts of ways. It's a really commonly used node. And basically, to create our linear gradient, we're just going to use UV coordinates. So I'm going to drop in a UV node here. And this node has two linear gradients built into it. If I add a split node here, and then we add a preview, what you can see is that the red channel coming out of this UV node is a linear gradient that's horizontal, and the green channel coming out of this node is a linear gradient that's vertical. And so this is how we're going to generate our linear gradient. So we have our UV coordinates coming in that allows the user to create their own UV coordinates, or we have the UV coordinates from channel UV0 here. And what we want to do is make it so that when this input is empty, when nothing is connected to this port, we want to use the default UV coordinates instead. So the way that I'm going to do that is I'm going to select the UV node here in my blackboard, and then I'm going to come over here to my graph inspector, and I'm going to check this box called Use Custom Binding, and I'm going to give this a label, and I'm just going to call this UV0. All right, now that I have it set up like that, I can add a branch on input connection node and connect my UV input port to the input and to connected. So what this does is when this input port is connected, it's going to use this value, but when it's not connected, I'm just going to go ahead and tell it to use the default UVs. The other thing that I want to do is come over here to color mode. I'm going to drop this down and change my color mode to category so that each of my nodes has this colored bar, and that allows me to see really clearly what kind of node I'm dealing with in each of these. I like to work this way as opposed to the default, which is none, which has no colors and is just kind of flat. So we're going to set the color mode to category. All right, the next thing that I want to do is I want to allow the user to invert the gradient. So I'm going to bring in my invert Boolean, and I'm going to add a branch node here. And we're going to branch based on my invert Boolean here. So I'm going to plug that into the predicate socket. And then if it's true, I'm going to add a 1- node here, which will invert my gradient. And I'll plug that into true. And then if it's false, I'm going to plug in the original result like that. Okay, so that's how I implement my inverse control, and the user can take that gradient node and invert the gradient if they want it to be white to black instead of black to white. Now, I did notice one thing, and that is, if we look at our preview here, this gradient goes from black to white, from left to right, but this gradient goes from black to white from bottom to top, which is not quite as intuitive to me. I would expect it to go from black to white from top to bottom. And so I'm going to fix that right here. Coming out of my branch node, I'm going to add a split. And now I'm going to add a 1- on my green channel so that my gradient goes from black to white instead of from white to black. Okay, now I have two gradients. I have a horizontal gradient coming out of my red channel, and I have a vertical gradient coming out of my green channel. And so I need to add two outputs. I'm going to add a U output, which is a float. And then I'm going to hit this plus icon here and add a V output, which is also a float. And now I can just plug my red channel in here and my green channel in here, and I've got my linear gradient node. So this is all set up to allow me to very easily bring a linear gradient into my shader. Now there are a couple of finishing touches that I want to make here. The first one is up here in my blackboard. Can you see where it says Subgraphs right here? Well, what I'm going to do is double click on this where it says Subgraphs and change this. And what this is going to be is when I right click or when I hit the space bar here and bring up this create node menu, the path that I type in right here is going to be the path that shows up in the create node menu. So you can see that I've got this procedural category here, and I've got a checkerboard, noise, and some shapes here. And what I can do is put this node into my procedural category. And this is a gradient, and so I'm just going to type procedural / gradients. And then I'll save it. And now when we open this up, it's actually not going to show up because I can't add this node to itself. But if I were to open up another graph, I would see inside the procedural category here a gradients entry. All right, so that was the first thing. And then the second thing that I want to do is come over here to my graph settings and set my preview. I want to set my preview to 2D. If you'll notice here, I have two-dimensional shapes. But down here in my main preview, I've got a three-dimensional shape of a sphere. And I'm able to set right here what type of preview I want to see from this node. So all of the nodes in this library, we're going to be setting our preview to 2D so that I get 2D previews instead of 3D previews like this. All right, now we've got a node that generates linear gradients. I'm just going to go ahead and save this, and let's take a look at what we can do. So I'm just going to create a temp shader here really quickly, and we'll open up our shader, and I'll hit the space bar and open up procedural. Now you can see, like I said, there's that gradient category. And now I have a linear gradient node, and it defaults to the preview being in 2D. And I can hit this invert box here, and it inverts the gradient. And I can take the gradient coming out of the U coordinate and get this horizontal gradient, or I can take the gradient coming out of the V coordinate and I can get this nice vertical gradient. So this is the very beginning of the node library that we're going to build together that's intended for generating procedural shapes and patterns. This is kind of like one of the most basic ones we can create. And now it's all set. We've got our first node in our library. All right, let's move on to making the second one. So I'm going to come in here to Shaders, Procedural Library, Helpers, and I'm going to right click and pick Create, Shader Graph, Subgraph, and we're going to call this one Anti-Aliasing. And I'm calling this Anti-Aliasing because it creates smooth anti-aliased edges, but really it's a lot more than that. This node that I'm about to show you how to make in the very first episode of the series is the secret sauce. It's one of the most powerful nodes in the library that we're going to build. This is the node that will allow you to create shapes and patterns that are resolution independent. This node will allow you to zoom in really close to a shape, and it'll still be perfectly sharp and nicely anti-aliased. I know that this is a lot of hype that I'm pouring into this, but I really can't oversell how cool this is. We're going to use this node in just about everything that we do, so I wanted to show you how to make it right at the beginning. Okay, so again, we're going to start out in our Blackboard, and I'm going to add two inputs here. The first one is a float, and we're going to call this gradient. So we're going to input a gradient into this node. And we need to set up a default for our gradient. And so again, I'm going to add a branch on input connection. And we're going to make our default the node that we just created. So I'm going to come here to gradients and add our linear gradient node. This is going to be our default. So when we don't have a gradient attached to the input port, it'll use the linear gradient node by default. So I'm going to wire this linear gradient node up to not connected. And then for our gradient import node, I'm going to come over here to use custom binding, and I'm going to type linear gradient here as the default. So this is the default when nothing is connected, and when something is connected, we're going to use that instead. All right, so we have our linear gradient coming in. And the next thing that we need to do is add a new parameter over here called cutoff. And so what this node does is it takes a nice smooth gradient like this, and it turns it into a hard edge. Now in this case, our linear gradient is going to have a perfectly vertical hard edge, but we can also pass in gradients that are other types of shapes like circles or capsules or those kinds of things, and the edge will be hard but also perfectly anti-aliased. And what we need to do right here with our cutoff value is define where along this gradient we want that hard edge to be. Do we want it to be right in the middle? Do we want it to be more to the left? Do we want it to be biased to the right? That's what our cutoff value is for. And so for a default value for our cutoff, I'm going to give it a default of 0.5. So that will cut it off right down the middle of our gradient. And I need to take that cutoff value and subtract it from our input gradient. All right, now the next part that we're going to do, this is where the magic happens. We're going to use derivatives. So I'm going to add a ddx node and a ddy node. And I'm going to connect the output of my subtract to both ddx and ddy. And then I'm going to make both of these into a vector 2 with the ddx result in the x and the ddy result in the y. And now we're going to measure the length of this two-dimensional vector that we just created. And then we're going to divide our original gradient by that length. And so basically what we're doing here, and you can see now we've got a nice hard edge. What we're doing here is measuring the distance of this gradient. And so this is the part that allows us to make things that are resolution independent. As we zoom in, this derivative bit here allows us to keep that edge sharp and anti-aliased regardless of how close or far from this gradient we are. So this setup allows us to create shapes that we can zoom in infinitely to and still have a nice sharp edge. There's just a couple of steps left. We need to subtract 0.5 here, or we need to subtract our result from 0.5. So I'm going to type 0.5 and subtract our result. And then we need to saturate so that our result will be output between 0 and 1. So now you can see we had this gradient here that was nice and smooth, and we've converted it into a gradient or into a shape that has a hard edge. And like I said, I'm inputting the linear gradient by default, but we can import all kinds of different sign distance field shapes and use this anti-alias node to resolve them to a shape with a hard edge. Okay, and then for our output, I'm going to convert this to a float, and we'll just call the output out. And I'll connect that up, and our anti-alias node is complete. Oh, but there are a couple of things we want to do at the end. Remember, we want to set our preview to 2D, and we want to set our path to procedural and we're going to call this one helpers, because this is kind of like a utility node or a helper node that we're going to use to get the results that we're looking for. Okay, so I'm going to go ahead and save our anti-aliasing node. And we'll switch back over here to the temporary shader that we've created so far. All right, so here's our gradient. And now I can right click and add our brand new anti-aliasing node that we just created. And you can see by default, it's taking in our linear gradient and it has a cutoff value of 0.5. So we can pass in our linear gradient here, And the result will be exactly the same because this linear gradient bit here is the same as plugging the U in this way. I could also plug in my V, and that'll give us a different gradient. And now if I add a slider node here, just temporarily, you can see that I can plug this into the cutoff, and now I can control where along this gradient my line is resolving to. So this cutoff value here allows me to control where my line will resolve to along the gradient. All right, we've taken our first steps into this really interesting world of creating procedural shapes and patterns with math. Next week, we're going to go just a little bit deeper. And so I've created this linear gradient node here, but we're going to create an assigned distance node that creates a circle. And then we'll be able to use our anti-aliasing node to create a perfectly smooth and anti-aliased circle. That's going to be great. I hope you'll come back for that one. In the meantime, let's jump over to Unreal, and I'll show you how to do these same things there. All right, here we are in Unreal. And if I open my content drawer here, you can see that I've set up my project so that I have a shaders folder, procedural, and maybe in Unreal I should call this materials instead because they call it materials. Shaders, procedural, and then I have a folder for gradients and a folder for helpers. And inside the folder for helpers, you can see I've created my anti-aliasing material function already. To create a new material function, I can just right click, come down here to materials and pick material function. That's how I created this one. And so let's go ahead and jump into anti-aliasing and create this material function. Now in Unity, we created two subgraphs, one called linear gradient and the other one called anti-aliasing. The nice thing about Unreal though, is that it already has a node called linear gradient. There it is. And this node does exactly the same thing as the one that we created in Unity, except it doesn't have an invert Boolean here like the one we added in Unity. So if we need to invert this, we can always just flip the UVs before passing them in. But there's our linear gradient node, and we're going to use that as the default input in our anti-aliasing node. So speaking of inputs, let's create two inputs here. We're going to create a function input, and this first one we're going to call gradient. And for the preview, I'm just going to wire in the U gradient of my linear gradient. And then I'm going to come over here and pick use preview value as default. And so that will make it so that this input will default to using the linear gradient unless I connect something. All right, and then the other input that I need to create, right now my input is set to a vector 3. And I just want it to be a scalar because it's just a black and white single channel value. All right, and then the other input that I need to create is going to be my cutoff value. So I'm going to call this cutoff, and I'm going to set it to be a scalar, and I'm going to set the default value to be 0.5. So now I need to take my input and subtract the cutoff. So I'm going to add a subtract node, and we're going to subtract cutoff from the input gradient. For my cutoff value, I also need to check this use preview value as default. Otherwise, if I leave the input port blank, I'll get an error. So I need to make sure that I check this use preview value as default box pretty much every single time. I wish that was the default in Unreal, but it's not. So we just have to remember to check that box every time. Okay, now I'm going to add my derivative nodes. I need my ddx and my ddy. And basically what these nodes are doing is sampling the next pixel over. So right now, every time I run this shader, it's trying to figure out what color a pixel is on the screen. And when I use these DDX and DDY nodes, it's looking at the next pixel over. This one is the next pixel to the right, and this is the next pixel up above, vertical. And it's saying, hey, what color are you? Because I want to use you to influence what color I am. And so I'm taking my DDX and DDY values here, and I'm going to add an append node and put the DDX and DDY into that. And then I'm going to take the length of that vector that I just created, that 2D vector, and I'm going to divide my original value by this value that I just calculated. And that's going to allow me to compare or judge the distance from the value in the pixel where I currently am and the next pixel over. And then dividing it is what creates our hard edge. And now we need to add a subtract. And I'm going to take a value of 0.5 and subtract from that the result of what I've done so far here. And then we just need to finish off by saturating our result. So we make sure that we don't ever get a value that's less than 0 or greater than 1. Then we can plug it into our output here, and our output is just simply called out. And now you can see I've got my nice gradient here, and instead of being a smooth gradient like it was to begin with, it's got a hard edge. And with my cutoff value here, if I increase this, it's going to move the edge to the right, like that. And if I decrease this, it's going to move it to the left, like that. So for now, we'll just leave our default right there in the middle. And like I said, when we were talking about the Unity version, this node is super powerful because it's going to allow us to take any gradient that we create, regardless of the type of shape that it's in, and create a perfectly anti-aliased smooth edge, regardless of how far we zoom in. So for example, if I were creating this gradient here with a texture, and I zoomed into it, there would be a point where I could start seeing individual pixels and it wouldn't look smooth. But with this line, I can go ahead and zoom in like as close as I can possibly get, and I can never get close enough to that line where it will stop being a nice, smooth, hard edge. Because of what we're doing here with our derivatives, where we're calculating the distance from one pixel on the screen to the next one over, and then using that to define where our edge is placed along that gradient. It's really great. And like I said, we're going to be using this anti-aliased material function for just about all of the shapes and patterns that we create in the next couple of months. So I wanted to create this node right away and get it to you guys so you can start experimenting with it, and so we can use it for the effects that we're going to create in the next series of multiple dozens of videos, I'm hoping, in this series. All right, so that's our video for today. Let me know down in the comments if you have any questions, and I hope you're excited to jump into this new world of procedural shapes and patterns that we're going to be creating and exploring over the next couple of months. I'll see you next week, and have a good one, everybody.